Welcome. In this segment, we'll talk about the different options you can do in Google Earth Engine to conduct digital image processing. And by digital image processing, in this first unit of digital image processing, we'll look at three different digital image processing options. And these are the gray level thresholding, the level slicing, and image convolution. And these are different image processing options that were described in a textbook. I will have the textbook name here. The textbook name is called the Remote Sensing and Image Interpretation, 7th edition. You can read about those different digital image processing background and what their purpose are. But we'll focus on how to do them in Google Earth Engine in this video. So let's get right to it. This first example shows you how to conduct a gray level thresholding. Gray level thresholding is simply a way to extract features inside the image by turning it on and off. In other words, just covering it or uncovering it. And it's very similar to the approach masking is doing. So let's get right to this example. In the beginning, on line 5, as we start there, this is simply just importing an image as we always begin doing in Google Earth Engine. And this is the example image I will be using to show you gray level thresholding in this example. And then from line 8 to 11 is we are displaying this image and center our map so we don't have to pan around to look at it. We also develop a study area, and this study area also help us to look at the image as well and to find this image on line 14. 17 is where we select the image band that is called B4. And this is the band that we want to use to conduct a gray level thresholding in this example to basically sample out all the water pixels out of this Landsat image. On line 20 is where we are building a histogram. And by building this histogram and display it in the console later, we will be able to see what the water pixels, their values are on a histogram. So we can pick that threshold of gray level thresholding. On 23 is where we actually display this histogram. And on line 29, that is where we actually apply this threshold of 0.07. And we will be able to mask out all of the water pixels inside the Landsat image that I imported earlier. And we apply this threshold by using this update mask. So this is a function simply, as I highlight there, it is used to get rid of all the pixels that is within the range that you are given it. So here we given the range as 0.07. Any pixel that is greater or equal to 0.07 will be removed in this case. And on line 32 at the end is where we display the image in our map. So let's just run it and we'll look at the console real quick. So in the console area, as you can see there on the screen, there is a histogram that was built just now. And the band B4 is a band that is commonly used to filter out water pixels. And this is the near infrared band. And water pixels does not reflect near infrared, and it does the opposite. It absorbs all the near infrared information. So we'll see a spike of region of values down below around 0.039 region there. So this is signaling us that the pixels within this range that is to the left of the histogram are probably going to be water pixels. So we pick a value that can illustrate a threshold level. So if we draw a line here, for example, at around 0.07, and we slice off all of these values to the left of the threshold, we will be able to get rid of the water pixels. And in Google Earth Engine, let me show you how this looks like when we apply this. So here, as you can see, this is the original Landsat image. So this is the original Landsat image you're looking at. This is all red, and the reason why it's red because I use the near infrared false colored composite method to display this Landsat image. But when we remove the water masks, so if we zoom on a region here that has a lot of water, for example, the Onondaga Lake here, we'll be able to see how the remove the water pixel image looks like. So if I turn off the original image and turn on this image here, this is after we remove the water pixels, and that is what you are seeing there. And it basically has no pixel and it makes it transparent. And now you're looking at the Google map down below that is showing you this is the Onondaga Lake. So simply, this is a very quick example of gray level thresholding. And the next approach we'll be looking at is the level slicing. So if I just display the code here in a second. So level slicing is a little bit different from the gray level thresholding. Level slicing example, you can be able to apply different levels or different slices, if you will, on that histogram we looked at earlier to assign a new value for the different slices of the histogram. And now we'll be seeing a image that will have different values that we assign it to based on the slice it is in. And let's just get right into this example. So first, as we showed earlier, it's a very similar example from line 46 to 39. This is exactly how we import image and display it, and I will not repeat that. The beginning on line 48 is where we are creating a we're creating a NDWI image, and this is the normalized difference water index image, as we have illustrated before in a previous video. And when we apply this image, we are going to assign different values to different slices of this NDWI image, so we can show a much better information using this level slicing technique. So here on line 51 is where we are assigning the different values to different slices. And if we focus on this code that I'm highlighting here from line 57 to 60, this is where we are assigning the values of different slices to different values. And here we use the near ND, which is the value of the near normalized difference water index for reclassification of these pixels. And we assign all of the value that is below 0 to a new value of 3. And we assign all of the value that is between 3 and 0.5, we assign a value of 2. And all the values that is between 1 and 0.5 is 1, as we show on line 59. And then all the rest of the pixels that are above 1, we assign a value of 0. And this is simply how you can construct a if statement to assign different values for those different slices. And then on line 64, we display the result of our level slicing. And let's get right to the result here. So if I run here, since we didn't print anything in the console, we have nothing to show there. But we'll show the result here on the map real quick. And first we'll show you the input image, which looks like a very familiar image that you have seen earlier. And I just zoomed it out a little bit for you to see it more clearly. Since we have made the NDWI image, we sliced it into 3 different values, or 4 different values, if you will. If I scroll it up here, you'll be if you recall, the values that we have reclassified are the values 0, 1, 2, and 3. And we assign these values based on the value of the NDWI image. And when we reclassify, we'll see a image that looks much more different. So if I turn on, you will be able to see there are regions where the image looks very differently. And now the image has essentially 4 different colors inside of it. There is the 0, 1, 2, and 3. And here, just to show you an example, if we go to the Inspector tab on the top here, when I click it, as you can see on the screen there, we can be able to get values in the image. So when I go back to the map here, now you see a crossbar at the mouse I'm pointing at. I'm just going to click over the Onondaga Lake. And now you'll be able to see something happened under the Inspector tab, as you see there on the screen there. And when you scroll down, you'll be able to see the value at that particular location I clicked inside the Onondaga Lake is a value of 1. So that means based on the values we assigned earlier, the pixel that I clicked on has a NDWI value that is between 1 and 0.5. And that confirms to us this slice was correctly assigned and the pixel is then correctly displayed. So if you have different layers of information inside of your image, you can simply create as many as slices as you want to reclassify this image for your own purpose. And that is the level slicing example. And the next example, I will talk about image convolution. And as I closed my map so we can focus on the code here. So image convolution is another way you can process image. Image convolution is oftentimes applied when there is simply too much information in a map, and you wanted to emphasize those features inside the image that has the largest feature or coverage inside a image that you want to look at. So for example, if you would recall the Onondaga Lake inside the Landsat image was very big. And if we look at the entire Landsat image, it's very hard sometimes to pick out that that lake area. So if we apply this image convolution, it will be able to smooth out the image, if you will, and now you'll be able to see much bigger features that stands out from the image itself. Why don't I just show you an example of that so it's better explained without my words here. So in this example, as we did very similar to the previous two examples, we import the image on line 72, and then we display this image on line 75 and 78. So those are not new, as we showed earlier. The actual image convolution starts with line 81. And this is the first time I am going to introduce to you this new function that is called ee.kernel.square. And kernel is simply a way of computing a neighborhood statistics. So if you would imagine a image has a pixel in a particular pixel inside of an image, there are different neighbors around that pixel. And if we want to smooth out that image or apply the image convolution, we would want to consider the neighborhood values of that pixel. And we can be able to do either average or median. So we can assign the same values to those pixels and then smooth out the image itself. So in this example, we are using on line 81 the EE kernel square, and this is a way we can smooth out by applying a box around the pixel that we want. And we apply a radius of 7, as I'm highlighting there. So we are basically constructing a 7 by 7 square around a pixel so we can smooth out that pixel value. And then we apply this smooth out kernel near image, and we apply this low pass filter as I defined here on line 80. And this is simply describing the smooth out process we are doing. And on line 84 is where we apply this smoothing process. And the process we call here is the low pass, which we described on line 81. And we use this function that is called convolute. It's called convolve. And this function applies the low pass filter that we have constructed earlier to give us the smooth image. So on line 85, we display this image. So why don't we run this script and we'll look at the map down below. So here, as you can see, this is the original image as we have shown to you earlier. And by applying the image convolution, we will be able to smooth out the image. So now the image looks like that. And now you will be able to see large features that stands out from the image. So for example, if I turn off and look at the original image, there are large areas such as the carrier dome near here. So if we just zoom into that region real quick, you'll be able to see near my cursor, there is the carrier dome structure that has a huge white colored roof there. And when we apply the smoothing algorithm, and if we focus on this carrier dome area, you'll be able to see that all the neighboring pixels around the carrier domes fades out, if you will. And the carrier dome feature stands out very well inside this smoothed out image. So this is a way for you to extract large images or large features, if you will, from an image that has simply too much detail that you would want to use. And that is the image convolution example. So in this video, we talked about the 3 different options that you can conduct digital image processing. Those are the gray level thresholding, level slicing, and image convolution. And in the next segment, we'll talk about additional options that you can conduct digital image processing, and hope to see you there. Thank you.